Good day everyone, welcome back to the continuation of our discussion on the topic integration. Today we'll be treating definite integrals. Definite integral is the integral on an interval a and b expressed as the integral of f of s ds b and a is equals to capital letter F of s, b and a, which is equals to capital letter F of b minus capital letter F of a, where we are giving our integration symbol. A is equals to our lower limit, b is equals to our upper limit. F of s is the function to be integrated, and capital letter F is the integral of f of s. We are going to be using some few examples to explain the concept of definite integral. Our first example states that evaluate the integral of s squared minus 1 ds. Our upper limit is 3 and our lower limit is 1. Now in our solution, our first step is to integrate it as normal, and doing so, integrating s squared to be equals to s cubed over 3 and integrating minus 1 to be equals to minus s. So our integral of s squared minus 1 is equals to s cubed divided by 3 minus s. Our upper and lower limit is 3 and 1. At this point, our next step is to substitute our upper and lower limit and subtract them from each other. That is, we are subtracting the lower limit from the upper limit. Doing so, it will be equals to, in bracket, 3 raised to the power of 3 divided by 3 minus 3 minus, in bracket, 1 to the power of 3 divided by 3 minus 1. Now simplifying both brackets, it becomes 27 minus 9 divided by 3 in bracket minus 1 minus 3 divided by 3 in brackets. Simplifying them further, it will be equals to 18 divided by 3 minus, in bracket, minus 2 over 3. Our minus is going to multiply and become plus, so we are left with 18 divided by 3 plus 2 over 3, which is equals to 20 divided by 3, and converting it to mixed fraction to be equals to 6 whole number 2 over 3, and the correct option is D. Our next example states that find the value of cos squared theta minus 1 divided by sin squared theta d theta, our upper limit being pi and our lower limit 0. Now to integrate our function, we are going to be simplifying the function first to something we can easily integrate. And from trigonometry, recall that sin squared theta plus cos squared theta equals to 1. So rearranging, minus sin squared theta will be equals to cos squared theta minus 1. So at this point, we are going to be substituting cos squared theta minus 1 as minus sin squared theta in our original expression. Doing so, the integral of cos squared theta minus 1 divided by sin squared theta d theta, with our upper limit being pi and 0, will be equals to the integral of minus sin squared theta divided by sin squared theta d theta, upper limit being pi and 0. Now dividing sin squared theta and sin squared theta, we are left with the integral of d theta, upper limit pi and 0, that is the negative, introducing our sign. So integrating the theta is going to give us theta, so we are left with minus theta, our upper limit being pi and our lower limit being 0. Having integrated our function, at this point we are going to be substituting our upper limit and our lower limit and subtracting our lower limit from our upper limit. Doing that to be equals to, in bracket, minus pi minus, in bracket, minus 0, which should be equals to minus pi. Our next question states that evaluate the integral of s squared plus 2s divided by the square root of 1 plus s ds. Now we are going to be integrating this using integration by substitution, and we are going to be using the substitution u is equals to the square root of 1 plus s. Now let u be equals to the square root of 1 plus s. Therefore u square will be equals to 1 plus s, and s will be equals to u square minus 1. Now differentiating u square equals to 1 plus s, we are going to be having 2u du over the s equals to 1, and cross multiplying, it becomes 2u du is equals to ds. Now our next step is to find our limit in terms of u. Now our original limit is 3 and 0, but remember it was when the function was in terms of s. Now to get our limit in terms of u, we are going to be substituting s into the equation to get an equivalent value for u. So when s is equals to 3, u will be equals to the square root of 1 plus 3, which is equals to 2. That is, we are substituting s into the equation. U is equals to the square root of 1 plus s. And doing same for our lower limit, when s is equals to 0, u will be equals to the square root of 1 plus 0, which is equals to the square root of 1, which is equals to 1. Now, applying all this substitution in our original expression, we are left with the integral of s squared plus 2s divided by the square root of 1 plus s ds, our upper limit being 3 and 0, will be equals to the integral of 2 and 1. Now for everywhere we have s, we'll be substituting it for u square minus 1. So it makes it to be equals to the integral of u square minus 1 square plus 2 in bracket u square minus 1 divided by u, and we are substituting the s for 2u du. So simplifying further, it becomes 2 because we are not differentiating 2, and our u will cancel out, so we are left with the integral of 2 in bracket u square minus 1 in bracket u square minus 1, that is, we are expanding u square minus 1 square, plus 2 in bracket u square minus 1 du. Opening our bracket, it becomes 2 the integral of u to the power of 4 minus 2u square plus 1 plus 2u square minus 2 du, our upper and lower limit being 2 and 1. Simplifying further, we are left with the integral of u to the power of 4 minus 1 du, upper limit still being 2 and 1. Now integrating u to the power of 4 minus 1, it will become u to the power of 5 divided by 5 minus u. So that will make our answer to be equal to 2 in brackets u to the power of 5 divided by 5 minus u, our limit being 2 and 1. So at this point, we are going to be substituting our upper and lower limits into our answer and subtracting. Doing so, it will be equals to 2 in bracket 2 to the power of 5 divided by 5 minus 2. That's substituting our upper limit, which is 2, minus in bracket 1 is the power of 5 divided by 5 minus 1. That's substituting our lower limit, which is 1. Everything in bracket being multiplied by 2. Simplifying further, we are left with 2 in bracket 32 divided by 5 minus 2 in bracket minus 1 divided by 5 plus 1 also in bracket. And expanding our bracket, we are left with 2 in bracket 32 divided by 5 minus 2 divided by 1 minus 1 divided by 5 plus 1 divided by 1. Simplifying our bracket, we are left with 2 in bracket 32 minus 10 minus 1 plus 5 divided by 5, which simplifies to be equals to 2 in bracket with the 6 divided by 5, which will be equals to 10 whole number 2 over 5. We have another question that states that using this substitution, u is equals to 1 plus s squared. Find the integral of 5s divided by 1 plus s squared raised to the power 3 over 2 ds, with our upper limit being 2 and our lower limit being 1. Now, using this substitution as requested, u equals to 1 plus s squared, our first step is to find the value of the s, and we get that by differentiating 1 plus s squared. Doing that, the u over the s will be equals to 2s, and by cross multiplying, the s will be equals to du divided by 2s. Now to get our corresponding limit, we are going to be substituting our upper and lower limit into the equation u equals to 1 plus s squared. So when s equals to 2, u will be equals to 1 plus 2 squared, which is u will be equals to 5. And when s equals to 0, u will be equals to 1 plus 0 squared, which is equals to 1. Now substituting for s and the s in our original expression, the integral of 5s divided by 1 plus s squared raised to the power of 3 over 2 ds, upper limit being 2 and 0, will be equals to the integral of 5s divided by u raised to the power of 3 over 2 du over 2s, with our limit being 5 and 1. That's our upper limit is 5 and our lower limit is 1. Simplifying, our s is going to cancel out, so we are left with 5 over 2, the integral of 1 divided by u raised to the power of 3 over 2 du. Now u raised to the power of 3 over 2 is the same as u raised to the power of minus 3 over 2. Now integrating it, it will be equals to 5 over 2 in brackets u raised to the power of minus 3 over 2 plus 1 divided by minus 3 over 2 plus 1. Our limit as 5 and 1. Simplifying our bracket further, it will be equals to 5 over 2 in brackets u raised to the power of minus 1 over 2 divided by 1 over 2, which therefore will be equals to minus 5 over 2 in bracket 2 divided by 2 raised to the power of 1 over 2. Simplifying further, it will be equals to minus 5 divided by u raised to the power of 1 over 2. Now applying our limits, that's substituting our upper and lower limit and subtracting, it will be equals to minus 5 divided by 5 raised to the power of 1 over 2 minus, in bracket, minus 5 divided by 1 raised to the power of 1 over 2, which will be equals to minus 5 divided by root 5 plus 5. Factorizing, to be equals to 5 in brackets minus 1 divided by root 5 plus 1, which is also equals to 5 in bracket 1 minus 1 divided by root 5. We have some exercises for you to try your hands on at home, and for further insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can easily get the hard copy in bookshop, or if you are interested in the soft copy, you can get it at the website at the bottom of the screen. Thank you.